So, good afternoon. So, in this presentation, I will be talking about ANFIS modeling. Full form of ANFIS is Adaptive Neurofuzzy Inference System. So, what I intend to cover in this is given here. So, I'll start with one example, a very basic one, which is like anyone can, it's easy to comprehend for anyone. It will be a generic example. And then I will be implementing that example in MATLAB. The approach which I will be using toolboxes, fuzzy logic toolbox. The approach which professor had given, he has used programming technique, but I will be using a much simpler approach, which is MATLAB toolbox. So first I will show you that example. I will implement that example in MATLAB using toolbox, and then I will be discussing one case study which I did using ANFIS, Adaptive Neurofuzzy Inference System. So there are two parts in this presentation. In first part, I will discuss the problem, a generic one, then what are the governing equations, and then how to implement in MATLAB using toolbox. So outcome of this presentation would be, after going through this 1 hour, you will be able to independently create your own models for your application. So to begin with, now you have knowledge about fuzzy logic systems. So when you see fuzzy logic system, this was a concept which was given by Lotfi Zadeh in 1965. And here, if you compare it with the binary logic system, in binary logic system you have 0 to 1. We go abruptly from 0 to 1. Whereas in fuzzy system, in fuzzy sets, we go from 0 to 1 gradually. Also, we make use of linguistic variables here. So that is why sometimes it is referred to as computing with words. So there are two types, popular types, Mamdani and Sugeno. Mamdani model was given by Ibrahim Mamdani in 1975. Second model is Tagaki Sugeno Kang, popularly known as Sugeno model, given in 1985. Both these fuzzy systems are implemented in MATLAB. So you have a toolbox that supports both these inferences systems. So let us start with example. Here, so this is an example. Now these days fuzzy logic is used right from our kitchen to defense equipments. It is everywhere, in industry as well. So this is the one household example where, so this is a washing machine and I want to design a controller for washing machine. I have few inputs and few outputs. So what inputs I have? I have two inputs here. I want to see how much is the dirt on the clothes and then how much is the grease present on the clothes. Depending upon these two, I want to calculate how much washing time I should give. If you want, you can add few more inputs, like I can also incorporate what is the weight of the clothes. So to keep it simple, I am taking only two inputs and one output. Okay. So once I have defined inputs and outputs, so these are the steps. The first step in implementing this fuzzy system is I have to define inputs and output variables. Then I will be defining the membership functions. Third step is to form a rule base, then a rule evaluation, and final step is defuzzification. So I'll go through all these steps one by one. And what are the equations? So all those equations I will be displaying, though professor had covered all those things earlier, but that was variable in the variable form. Now it is in example form. Okay. So as I said, there are two inputs and one output. So two input, dirt and grease. So further dirt I am dividing into three categories. First category I am saying small dirt, which is denoted by SD. Then medium dirt. Okay, dirt I'm having, like I'm taking three levels: small dirt, medium dirt, large dirt. Grease again three levels: no grease, medium grease, and large grease. Whereas output, for output I'm having five levels. So we call it descriptors. So very small, short, medium, large, very large. So this is the total system. You are having two inputs, one output. Input dirt and grease. So this here you have wash time. That is my goal. I want to calculate washing time. So now I will be defining membership functions. So there are many types of membership functions, but the simplest one is triangular membership function, which is used here. Here on x-axis it is dirt, y-axis the value will vary from 0 to 1. Membership function can vary from 0 to 1. On x-axis we have dirt is given in percentage. I am taking percentage. Small dirt, this side I am mentioning small dirt, here I am mentioning medium dirt and large dirt, and then I am basically drawing these lines. These lines are called triangular membership functions. So small dirt is going down, it is high here, going down here. Medium dirt, it starts from here, it is maximum here, then it goes down here. For large dirt, it starts from here and it goes like this. So you can see membership functions are varying from 0 to 1, not suddenly, but gradually, increasing or decreasing, gradually. Now, I have to write this membership function, the equations. The equation for this, I have to mention the equation for this. What I will do, I have to define slope. What is the slope of this line, basically? So here, I assume this as x. I have to define this line. So it is, membership function is denoted by mu. So mu x. So I have to define the equation for this. So equation for this is, you assume x as here x as x. So it will be 50 minus x divided by 50 minus 0. So 50 minus x and 50 minus 0. I say, like, it is, in order to be to make it simple, I say if I am assuming x here, so this is my leading edge, this is my trailing edge. So leading edge divided by leading edge minus trailing edge divided by leading edge minus trailing edge. So it is a layman's language, but easy to comprehend. So basically I am defining slope of this line. So this is, so I have defined this this equation. I hope it is clear how we are defining this. And this equation is valid in this zone, 0 to 50. So 0 to 50. Small dirt membership function is valid within this range, 0 to 50. On the other side, you have when it is large dirt. So large dirt is here. So in order to define large dirt, I assume here you have, say, x here. So leading edge, so x minus 50. So x minus 50. Leading edge is 50 here. 50 minus 100 minus 50. So you get this. But for medium dirt, so there are two lines. I have to define these two lines. For large dirt, the range is 50 to 100. So 50 to 100%. For medium dirt, there are two lines. I have to define these two lines. For this line, the range is 0 to 50. Again, we do same thing. So assume x here as x. So leading edge, this is leading edge. So x divided by 0, x minus 0 divided by leading edge minus the trailing edge, 50 minus 0. So x by 50. So range is 0 to 50. On the similar lines, so I will be defining this. It is defined here. So I hope it is clear how it is defined. So once you have defined this one, same thing you will do, exactly same thing you will do for the second input, which is grease. So here also, no grease, medium grease, large grease. So three levels. On the similar lines, you get these equations and you mention what is the range in which that is applicable. Exactly same thing you will do for the outputs. Outputs I'm saying now I'm having 5 outputs. 5 descriptors, very small, small, medium, large and very large. So these are the equations which I get for the output on the similar lines. Is it okay? So yesterday also it was mentioned by professor there are different types of membership functions. So there are many types of membership functions you can see here. But simplest one is triangular and most of the time so Gaussian is also used, whereas other trapezoidal, singleton and piecewise linear is also available. So once I have defined inputs, I have fuzzified it, I have fuzzified outputs. Now it is time to do the middle part, which is I have to define the rule base. In order to define this rule base, I have a matrix like this. So X is say dirt and Y is grease, dirt and grease. For dirt you have small dirt, medium dirt, large dirt, grease, no grease, medium grease and large grease. I have to take decisions now. In order to make this one, you can have knowledge of the expert, or you can define the requirements of the problem here in order to have the output which you want. So for example, I know from intuition I can say that when dirt is small and when there is no grease, how much time I should give? So I should give very short time. So there is no ambiguity about that. Similarly, when it is large dirt and large grease, how much time I should give? So very large. If it is medium, so I will settle down here. Remaining blocks you can fill accordingly. Okay. So this is the most important thing here. So create a rule base. So once rules base is created, next step is I have to give these. So now I'm having in this rule base I'm having 9 rules. So I will be giving this 9 rules in the next step in this form. So all those 9 rules which I have given here, that if it is dirt is small, grease is say no grease, the output is very small. Okay. So you can see it is the first rule which I am mentioning. Same way, if dirt is large, grease is large, the washing time should be very large. So all 9 rules I have to give to the system like this. Now I have to evaluate, I have to get results. Now I will be evaluating these rules. So what will be the result if dirt is 60%, grease is 70%, because I am interested in knowing how much washing time I should give. Dirt 60%, grease 70%. So when I am saying dirt 60%, so that time you recall your membership function for dirt. Membership function for dirt is here. 60% is somewhere over here. 60% here. So 60% is here. Now when I move up in this, so 60% will be, I will be cutting LD and I will be cutting medium dirt. So 2 lines I will be cutting when I move up. 60% is here. So when I move up here, so I will be cutting large dirt and medium dirt. So this is what is, I know the formula for MD. What is the membership function for MD? It is here. So we just saw now. Are you getting it? So and for LD, what is the membership function? That equation is here. This one is for MD and this one is for LD. So there is a combination of medium dirt and large dirt. So I have obtained this. Then for grease, so this is the membership function for grease, and when I see 70%, 70% is somewhere over here, and when I move up the line, so it will be cutting again LG and MG. Okay. Again, it is cutting two lines. So I am having two membership functions again, which is MG. This is the equation which I know, and this is the equation for LG. So two equations. So two equations I've obtained for dirt, and two equations I have obtained for grease. Is it okay up to this point? Now I will be evaluating it. In order to evaluate, so what I do, I want to evaluate at 60%. So when I want to evaluate at 60%, so x I will be putting in this equation, I will be putting x as 60. Simple calculations. So instead of x, now 60. So I get 4 by 5. In the second equation, I put 60, so I get 1 by 5. And here for this, I get 3 by 5, and for this I get 2 by 5. So 1, 2, 3, 4. So 4 values. So I'm getting 4 equations now here. This one is evaluated at 60. This is evaluated at 70. Now what I want to see how many rules I have. Out of 9 rules, how many rules I will be evaluating. You see, I will try all combinations. I will see 1, 3, 1, 4, 2, 3, and 2, 4. So I want to try all 4 combinations, all combinations. So in this case, earlier I was having 9 rules, but now when I am evaluating it at particular level, then I have contribution of only 4 rules, and that is 1 and 3, 1 and 4, 2, 3, 2, 4. So this is 1, 2, 3, 4, 1, 3, 2, 4. So out of 9, now only I have contribution of 4 rules. Now I will check strength of each rule. How much is the strength of each rule? So in order to check the strength of each rule, so S1, the first rule, S1, I will be taking minimum of these two. Minimum value for 60, this is 60, this is 70, so minimum of these two. So minimum of 4, 5, and this one 3 by 5, so minimum of these two is 3 by 5. So this is the outcome of first, this is the strength of first rule. Same way I get strength for second rule, third rule, fourth rule. So I'm having, in order to get strength of each rule, I'm using this minimum function here. So now here I'm having strength of all the 4 rules. So what next? So which rule is now important? So for defuzzification, so maximum strength. So out of these 4 rules, out of these 4 rules, which one is having maximum contribution? I will be considering that. So out of these 4, S1 strength of first rule, second rule, third rule, fourth rule, out of these 4 rules, which one is having maximum strength? It is 3 by 5. So maximum strength is given by first rule. So I will consider only first rule for defuzzification. Remaining other rules are gone. Is it okay? Okay. So now what the first rule says? First rule says when dirt is medium, grease is medium. So this is the first rule. Okay. Just go back. Dirt is medium, grease is medium. Now what should be the result? What should be the result? When grease is medium, when dirt is medium, grease is medium. So what should be the result? So it should be minimum. So I can see from the rule base, it should be minimum. Coming back here. Okay. So it should be medium. It should be medium. That means here you can see. So this is referring to as medium. So output here is medium. Medium means, so I will be referring, this is my membership function for the output. So I will be referring to only medium membership function here in the output. Others are not important for me as far as this evaluation is concerned. So I will be looking at only medium value, medium membership function, this triangle only. Now this triangle is having two equations, one equation for this line and one equation for this line. And here is that equation. This equation, this line is defined here, and this one is defined here. You know how to do how to define these membership functions. Now I will be evaluating for 3 by 5. So 3 by 5 I am keeping here, and from here I am calculating value of z. Calculating value of z. So value of z which I get here is 19. Same way I will be evaluating value of z here. So I'll keep 3 by 5 here, and from there I get value of z. So I get 19 here, 31 here. Which one value I should take? So for the time being, I am taking use. So which comes out to be 25 minutes. So this is defuzzification. So I have from input. First I created inputs. I located. So what were the steps? First was define inputs, outputs, and then create a rule base. Then give rules. Then all these steps you follow, so you will be able to get the results. Now, as we have many methods of defining membership functions, we also have many methods of defuzzifying. So there are many methods for defuzzifying. Professor touched a few methods, if you recall yesterday. So the method which I used, very simple method, was the average one. Now, next step is to implement it. Implement it using fuzzy logic toolbox. So I have a small video here, so I will be playing. So I have recorded all my activities. So I will be explaining along with that. So when you enter fuzzy logic, when you open MATLAB, on that command line you write fuzzy. Then you open fuzzy environment. Okay. So you will give inputs. So I will be sharing this video with you. For the time being, you can just see. So I will be defining inputs. Here I am defining, say, dirt. Then second click on the second input. So it is defined. Now I'm selecting the output. Here I'm mentioning the wash time. Okay. So once it is done, so wash time. Yeah. So next step is you double click on this input, and then you have the membership functions here. Either you can enter. So first thing is you define the range. So this range. So range you are defining. I'm taking it percentage. So I'm defining 0 to 100%. The membership functions. I can just select and drag, or I can enter values here. Okay, I can enter values here, but for quickness, I'm simply dragging and dropping, and then I'm defining the like names for this one. So this is SD, this is medium dirt, and again drag drop, take it to proper location wherever you want to have it. Now the third one is what was it? It is large dirt. So large dirt. So here there is a problem. I have not pulled it. Now grease. Select the range. Again 0 to 100 here. 0 to 100. Again pulling the third one. So triangular membership functions are set. Naming it. So this was no grease, NG. No grease. So medium grease. So it is a short clipping in 1 minute or 2 minutes maximum. It will take more. So large grease. And now this one is not properly designed. Like I need to pull it further. This also, this side. You can do it manually, but manually is not that accurate. So it is better if you enter those values here. Okay, values for triangular membership function. Okay, so pulling it, making it, trying to adjust, but you see the values are not accurate here. If you are trying to do it manually by clicking, dragging it. So inputs are defined, membership functions are defined, output membership functions are also now we are defining it. So I'm for sake of simplicity, I'm taking only 3, but in the example which we took, there were 5 descriptors. Now only 3. So low, medium, and high. Small watch time, medium watch time, and very large watch time. Okay. So now I will be entering rules. So for the time being, I am entering only 3 rules which are important: low, medium, and high. There are many rules I am not including, like small dirt. If dirt is small, grease is small, then output is very small. So first rule is entered. So you can click here, and add rules. So it is very easy to add rules. So 3 rules I have added. With this, it will work. Now I will see rules. So you can see in the rule viewer, I can see how it is working. So this is, if dirt is 20%, grease is 70%. This is my time. Wash time is 29.9 minutes. Okay. So you can evaluate, and you can also see surface. Surface plot shows how it is behaving. What is my decision surface? So you have X here, grease, dirt, and this is the decision surface. What is the decision? How it is behaving? So this is how you can create fuzzy model using toolbox. It is comparatively easy, especially for non-programmers. But as an engineer, you must use approach which was taught to you by professor, programming approach. That is the best approach these days. Without programming, engineer cannot survive without programming. So you must do programming approach. This is something like quick. If you want to have a solution quickly, then this is the approach which is used. If you have any question up to this point, you can ask. The second approach which I will be talking about, that is ANFIS. In that they will be using that second approach. I will be answering that question as we go further. So if you remember, yesterday professor covered it very nicely. So it is the it is for this approach, it is like that. So you have to use like this. Or if something else can be done, sir, may I have your comments on this?
Basically, for this party, okay, then basically just different. And it could be different, but differences are kind of minor. They are similar because they're fast. So we can also say, I mean, which one is better than the other. I mean, we can also say. But we do have, I mean, several different, I mean, several ways when they are slightly different, but they are similar.
Okay, thank you, sir. So in this approach, this modeling technique, it supports the second method. Uh, two modeling techniques. One is Mamdani, and second is Sugeno. So this method. I've used the Sugeno approach. What is that? Shortly, you'll come to know what is that. So this is a case study which I performed. Now the goal here was this is linked to condition monitoring of cutting tools. Now condition monitoring as a generic area, you can apply condition monitoring to any field. So like for basic things, for condition monitoring you should have sensors. The modeling technique will remain same. Okay, should have sensors and the model will be same. So I performed one study. So this was a topic which this study we performed here, but based upon this study I also did some work in Norway, that was condition monitoring of wind turbines. So you see, application part is different, but the concept, everything will remain same. Sensors, data acquisition, and then create models. So the models which we are talking about here, these models are like not analytical models. So these models are good. If you have a lot of data with you, then these are the best modeling techniques. AI techniques normally, for that you should have huge data with you. Then only these techniques are good. Otherwise, if whenever there is an analytical solution available to any problem, you must use analytical models. So that is a word of caution here. So these techniques you should use when all other techniques fail and you have a lot of data with you. More number of variables, huge data, go for AI techniques. Okay, so condition monitoring. So what I did, how many of you are mechanical side, mechanical engineering? Okay, so in this, we have a cutting tool. I'm interested in knowing what is the condition of the cutting tool. So what I'm doing, I'm putting three sensors. I'm putting here in this figure. You can see while doing machining, what we are doing. I'm putting three sensors: vibration sensor, acoustic emission sensor, and cutting forces. So I'm performing experiment. I'm recording all these values. I'm acquiring data with me, and then after experiment, after one cut, I am measuring how much is the tool wear. So I do a lot of experiments like this, continuous experiments. I have say 500 experiments. After each experiment, I am measuring how much is the tool wear. Now those 500 data points I have, using that I will I created a model using adaptive neurofuzzy inference system. If you ask in the fuzzy system how to get the membership function, how to get membership function in order to have proper results. In adaptive neurofuzzy inference system, the membership functions will be you will automatically get membership functions also. So what thing you need to give to in order to have ANFIS implemented, you need to give only the inputs, and then using that toolbox, there are just few steps. Using those steps, your membership functions are you will get all membership functions. You will get all rules as well. So it is a completely automated thing. So adaptive, it is an iterative process. In one pass, it will do something. Again, it will see error, and then again it will do second pass till the error is minimized and you get the results which you are looking for. Okay, so looks like this. So here I was using time, forces, vibration, acoustic emission, and the output was tool wear. So these models will work if you have experimental data with you. Then only you can apply. Okay, if you don't have anything, so these are like data-driven models. The right word is data-driven models. Okay. So these are the different membership functions which software will generate. So the algorithm will generate all membership functions for you. So I told you that I have performed about 200 experiments, but here the mapping is done only by 10. So you see only 10 membership functions. So why otherwise you should get here say 200 membership functions. So why only 10? Because I performed clustering. So before I performed clustering, so instead of having 200 data points, now I get clusters, say 10 clusters. For those 10 clusters, so this is the membership function for each cluster. And my I'm getting the results which I was looking for, the right kind of results I get. So 10 clusters are good enough to fetch me the results which I'm looking for. So these are the rules. So 10 clusters, for each cluster one rule. This will also you will get automatically. And these are the results. Results are quite encouraging. Like you can see, predicted one as black and actual tool wear as red. So very close matching of the results. As I said, that modeling part here is data driven. You should have a lot of data with you. Then only these models are good enough. You can create good models. Now, when I have data, so how many data? So there are three things which I require for this data. One is training data, training set. Then second is testing, training, testing, and validation. Three things are required. I require three things in this. Three sets of data. So 70% of the data I am using for training. 70% of the data. So out of 200, 70% of the data I will be using for training. 15% of the data I am using for testing, and 15% for validation of the models. So once I'm satisfied with the results, then only I can deploy it in actual application. So till then, so you need to readjust things in order to get the accurate model. Now, how I select this data? So out of, say, I'm saying 70% data for training, 15%. How to select? You can select randomly, or there are other algorithms also. You can use a particular technique for selection. Now you're interested in knowing how to implement it. Implementation is very simple. You need to give only one file. This is the file which you will give, and rest everything is you will be clicking few buttons, your model is ready. So you need to give a file in this format. So this is first column, second column, third column, and the last column is my output. Last column is my output. In this case, it is a tool wear, and this is first input, second input, third input, fourth input. So I can have n number of inputs. Output would be only one. So in this case, it is tool wear. So this file, I'll create this file and I'll store this file under this name, say any name dot dat file, data file dot dat. That is important. So go to MATLAB. On the command prompt, write ANFIS edit. ANFIS edit. So you will get this thing on your screen. From here, you have training, testing, and checking values. So here, first you click on training, load the data from the file. It will appear like this. Then you will generate FIS, train the model, and see the structure of this, and then you can close it. When you close, it will ask you for saving it. Save it. So this is the structure which you will see. Save it, and then your model is ready. Fuzzy inference system is ready. Go to again fuzzy logic. On the command prompt, write fuzzy. Load this. Get into the fuzzy environment. From there, you load the file which you have saved. So this is your and now you can check you can see how it is behaving. You can enter the input values here and see the output here. Okay. So again, I have one publication on this. It is published in Journal of Intelligent Manufacturing. So I'll show a video to implement how it is implemented. So first thing is I want to give input. So in order to give input, so what I have, yeah. So I have the input in Excel file. So I have say input in the Excel file. What I'm doing here is I'm simply copying it, and so copying it, going to fuzzy logic environment. There I'm creating new file, open new file, copying the data which I have Excel file there, then saving it under that name with dot extension, with any name with dot extension. So once I have done that, next step is ANFIS edit. So training data, load, so loading the data. So input is loaded. Okay. Then I will be generating FIS. So when you click on this, it will ask you which membership function you want to implement. So here it is asking me which membership function. So for the time being, I am saying this triangular membership function. So next step is to train. So in just 3 iterations, I'm able to train it, and this is the structure which I get. Okay. Sometimes you will get many rules in case you want to reduce. So sometimes when you get huge number of rules, so we say it is explosion of rules. If you want to reduce number of rules that you are getting, so you will go for clustering. You will go for clustering. So these are the rules which you get in normal case. If you want to go for clustering, so when you want to go for clustering, so the clustering which is implemented here is subtractive clustering. So you click on subtractive clustering and then say for the time being whatever are the default values, you keep them as it is. So you will be able to reduce number of rules. So using subtractive clustering. So close it. When you close it, it will ask you to save it under particular name, whatever you want to give. You can give that name. And then I will be entering so I will be then I bring it to So then I open fuzzy environment. There I call this file, and I can evaluate it. Actually, I am zooming it, so that is why it is running here and there. So it's yeah. So now my model is ready. So you see the membership functions, rules. So rules are also automatically there. You can see. So you can evaluate also. You can give the input here, and it will give you the output. So this is how it is implemented. And when you are using ANFIS, so you need not give anything, like you need not define even membership functions. So everything is done for you by the software. So this is the rest. Everything remains same for whatever you can do with the fuzzy logic. Same thing you can do with the ANFIS also. So adaptive neuro fuzzy ANFIS system is so here the membership functions are decided by the algorithm itself. So this is you can evaluate your rules here. If, so you can give the inputs X. So whatever the inputs you have here, so you simply give your inputs here, press enter. So your output will be displayed here. This is the article which I published. I have just shown you. So the concluding remark is, so these are like evolutionary algorithms. These should be used only if other things fail. As an engineer, I must go for analytical modeling. Then if I'm not able to handle the things using analytical models and number of variables are more, huge data with me, go for evolutionary algorithms. More data you have, more is the accuracy of the model. So these are some references, and thank you very much. If you have any question, you can ask.
Regarding that data set selection, you choose the combination of 70-30. So have you tried to think of 60-20-20 or 95-5? Or is there anything, something like we have grid sensitivity study in CFD?
Okay.
So such kind of thing is done before coming to this optimum choice of 70-20.
No, for my study, I did what I've shown. So I have not tried the thing which you are saying, like other things. So I have not tried to optimize those things. So this study I did in long back, about in 2006, so which was published in 2008. So that time this was a new concept which was there in market. So as a mechanical engineer, so and anything which comes new, so we should be able to use it for our application. This is our normal mechanical engineer will try to do like this, rather than going into intricacies. What if I change this? So that maybe somebody might have done it, but I have not done it. I have not done it. Interfacing. Uh, Sir, you have some idea about interfacing. So model is ready, but how to interface?
You're talking about these real time, right? Yeah. Real time control, right? You're in MATLAB, here MATLAB means, okay, first you collect a lot of data, you train this one. But when you, get this, data from sensor, you will just, okay, enter this data manually to the, MATLAB system. Usually for the real-time control, for example, if you try MATLAB, usually for the real-time control, the sensors, we use a live view. We don't use MATLAB. I don't know whether MATLAB has such a function, but usually we use another real-time control.
Okay, thank you, sir.
When it's a real-time, for example,
whether this real-time data is coming from sensor or when it is already trained model is there. This
sensor,
will be a software only, right?
you
It has to be connected to machine and it has to be ordered.
Yeah, for example, for the real-time control, that means, okay, when something happens, and okay, then you collect the data continuously. Then you also instantly the condition result continuously to update your model, then to improve model. Okay, that is real-time. We do have something, but I don't know whether MATLAB is appropriate one.
So with LabVIEW, certainly it can be done, because LabVIEw, it's by a company called National Instruments, and they have in whatever we are doing, it is in digital domain. So they have interface cards. So sensor is giving output analog domain, whereas my computer understands digital. So you required a card in between, which is called analog to digital converter. Same way, if I want to control motor is again analog thing. So I required another card here, which will convert from digital to analog domain. So those interface cards are available by that National Instruments. And LabVIEW, using LabVIEW, you can control both the things. So that is probably what Professor has mentioned.
I think probably if I use something MATLAB to train, you have offline data, past data, historic data, you can train MATLAB. Then you can LabVIEW. I believe that LabVIEW can execute some software packages, for example, C or C Sharp. I believe most software systems have such software.
So, actually, you have done the modeling for the tool here, and the tool here will be very less.
Very less.
Very one mass. For predicting, you have made one model with help of ANFIS, but in the reality, they are using for a very large time, and then after the tool here will be done, it will not be even visible form. So whether this particular model that will be efficient because the model runs for very small period of time, and we are having the actual data after 20 minutes. Because I'm asking, we have done the experiments for suppose 5 to 10 minutes of a particular insert, and you require the data of how much will be made after running of the 50 or 60 minutes. So whether it will be efficient.
So what I did experimentation to the up to the end of life. Like I did one cut, did measurement, and then put same tool again, did second experiment. I continued like this till the tool break. So I went up to the end. So like models are quite accurate. The accuracy of the model, it depends upon what data we give. So definitely. So
For clusters, we have made that 10 clusters.
yes.
So that clusters are based on the cutting parameters, or how you have.
No, it is done automatically. You cannot change clusters. So in this where it is implemented, so it is taken automatically. So that is why the programming part is important. So here they give some features which you can add, but some features you cannot change. That is why programming is important. In programming, when you write a program, you have full control on that. So you can change, you can tweak any parameter which you like. So that is why programming is important. That is why programming is important. Otherwise, in toolbox, you can do something quickly, but ultimately, you will not have complete control on the parameters.
Sir, if we select the Madani, then is there any change in the output?
So, in
Accuracy will be changed, or like that? Is there any?
I don't think accuracy will change. What is difference is what is the difference? So here, first two parts, like both these models, the first two parts are same. First two parts. Only the defuzzification part is different. So here you have defuzzification in Sugeno. So the output, only the output method is different. In Sugeno, you have membership functions which are either linear or constant. So only the output technique is different. Here in memory, you have everything in a fuzzy domain, and then you need to defuzzify. Here you have you have membership functions in linear or constant domain. As far as the accuracy is concerned, I don't think there would be difference. I hope, sir, it is right. Accuracy would not change.
Something is hard to say which one is better.
Yes, yes. Yeah.
There's some discussions, for example, we have different models. Okay. Then in this the application you use this model. In this application you use another model. But sometimes it's hard to say. It's hard to say because it's just hard.
Sir, for beginners like us, suppose we are conducting any research on such topic, is it recommended that first we should go for ANFIS and then getting some result and then go for program?
It is better if you use toolbox. Using toolbox, you can create model in 10-15 minutes. You just saw. So, like sir said, you should create a form groups and do some project. So that way, if you use toolbox, you can implement it in 10 minutes. Then you will start liking it. But later on, the word of caution is later on you must go on programming.
So from like ANFIS, adaptive neurophysics system.
Yes,
What we saw was like fuzzy.
fuzzy.
What we study is fuzzy. So what is the purpose of adaptive neurothing?
So that membership functions, how you are getting membership functions. So there it is a hybrid system where it is a combination of neural network and fuzzy logic. Base is fuzzy logic, but in order to decide the membership functions and the rule base, their neural network is like playing a role. And what is neural network? That is the next thing which we'll study. Okay, thank you very much.